Welcome back to the course. We'll be getting the foundation of our player up and running today, and we'll also be learning more about functions and why we use them. Quick thing to note, we'll be learning how to quickly design a player character, then in future videos, after we've kind of settled with what our prototype will be, we'll be coming back and redesigning our player in a much more complete and expandable way using a handler and component system, or handler or component system, that we'll be able to reuse parts of, so we can kind of add them to enemies, and it just makes it so we don't have to recode or redesign everything anytime we want to create something. Anyway, with that out of the way, let's actually go and set up our player scene. Now, I'm in the project here, and all we have to do is click this little plus icon in the top corner. This will add a new scene. And then what I'm going to do, where it says create root node, is I'm going to go down to other node. Now, our player character is going to be a physics body type, right? And the type that we're going to want is, or the node we're going to want to have as our root is going to be the character body 2D, which you'll see. If you type in CH or you type in character in the search bar here, you'll see here that we've got this little tree and it comes down to character body 2D. Now, very quick thing is how this is kind of working, right? Every node in Godot comes from this base node type, and then it has a canvas item type, then a node 2D type, then a collision object type, then a physics body, and then finally the character body. What this is kind of saying or telling you is the character body 2D is inheriting from all of these to create what it currently is. We will be going into custom inheritance. Basically, we'll be using inheritance in our own way in the future, so look forward to that. Anyway, for this, we're going to click character body 2D. We can either double click it or we can just hit create, and it'll create a new character body 2D for us. Now, we're going to rename this. We're going to just call this player entity. You can call this player if you prefer to just call it player. I prefer to call it player entity. Entity for me is a very specific word. Pretty much anything that can be considered a quote unquote entity or like a moving object of some sort or a non-level related object or a non-static object really is an entity to me. Now what we're going to do is we're going to hit Control S and save. We're going to save this into the scenes folder under a new folder, and we're going to call this player, and we'll hit save. And now we need to actually compose our player entity. Now, to compose our player entity is actually relatively simple. All we have to do is add certain types of nodes to kind of get it to do the things we want. So you'll notice that we have nothing to view here. So what we're going to want to do is click on player entity, and you can either press Control A, or you can press this little plus icon, or you can right click, add a child node. I'm going to press Control A to add a child node. I'm going to type in sprite 2D, or just sprite into the search bar, and we're going to grab a sprite 2D. You can use an animated sprite if you want to. Personally, I prefer using a sprite 2D and then an animation player to do animations, which we'll also get into. So we're going to add a sprite 2D. Now let's go into our file system down here, into assets. Now into our pixel platform asset pack, we'll go down into tiles, characters, and we're going to pick a character. Now we can pick any character here that we actually want. I'm going to go with, let's go with the blue character, so the blue little alien. Now if I just scroll in a bit, there are two little issues with this that we're going to consistently kind of run into with this specific asset pack when it comes to character types or character tiles or sprites. And that is, one, the offset is centered here. So the center of our character is on the center line, and completely centered on our X, Y, and Z. We won't want this. And the other problem, of course, is it's looking left. We want it looking right. So to change this, we're going to go to offset first, and we're going to see where it says flip H here. We're going to turn that on. It's going to flip our character to the right, so we're now looking right. Now we're going to come down into the transform. Actually, we'll do this through the offset. The offset's got to be a better idea. We're going to basically just move the y-axis here up. Now, there are a few ways you can do this. If you just click and hold on Y, you can move it left and right to move up and down, like so. You could also just type in the number you want, which in this case will be -12 pixels, like so. That makes it so our character's feet are on the x-axis line or the floor. So that centers our character nicely on how we want it to be, and it allows us to flip our sprite. So that's our sprite handled. Now, if I put this in the game, it's not going to do anything, right? Even if it could do something, it won't collide with anything. And to fix that, we're going to need a collider. So if you actually hover over player entity here and you go to this little warning symbol, it says here there's a node configuration warning. It has no shape, so it can't collide or interact with other objects. Consider adding a collision shape 2D or polygon 2D as a child to define its shape. Now, that's actually really simple. All we've got to do is add a node to our player entity here, and then we're just going to add a collision shape. So collision shapes are kind of shape like primitive shapes in like some sense. They are, the relatively set normal shapes that you'd be used to in the game dev environment, where it's like circle shapes or rectangle shapes or capsule shapes. For our player, you might be tempted to use a capsule shape. I always usually find it's better to just use a circle shape. So we're going to use a circle shape, and then we're going to click to our move mode, or we'll press W to move to our move mode. Now we are going to move this up, and then we're going to go into our scale mode. We're going to scale it in a bit. When designing hitboxes and collision shapes, usually what you want to keep in mind is, and we'll get more into this when it comes to making hitboxes and hurtboxes, but what you usually want to keep in mind is how the player is going to feel depending on how the hitbox and hurtbox works, right? Or in this case, what if they're jumping from platform to platform? How are they going to feel if their toes touch the platform, but they don't collide with the platform and they fall off? That can tend to cause some kind of issues. Now, that's kind of one of the reasons why you might want to use a capsule shape rather than a circle shape. But circle shapes tend to work quite fine. So in this case, we want it kind of centered around the character's main body. We want it to be touching the bottom floor where our toes are or where our feet are. And this should kind of feel pretty good. Now, once again, we can go back and tweak this in the future, and that's perfect. Now, with our sprite and our collision shape added, we're going to add one more thing, and that is going to be an animation player. Now, animation players are kind of what the name entails. They are there to play certain animations. Now, the reason why I use animation player over a animated sprite is because there's a lot more you can do with an animation player than it is for an animated sprite. And as I said, we'll get into that when we actually get into the animations and things. For now, we don't really want to worry about animations or other kind of flashy things. We just want to get the player moving around, maybe get it jumping around, and kind of go from there. So, with our node composed, or our player entity composed, we now need to go and add a script to it. Now, you might be tempted to just go straight up, click the script button. Go careful with this. You have to make sure the thing you want to add a script to is highlighted. So in this case, the animation player is highlighted, which means if I add a script, it's going to add it to the animation player. We don't want that. We want to highlight the player entity and then add a script to it. Now, the path will just be under the scenes player folder. Then I'm going to click create. Now, usually when you first start in Godot, if you haven't changed any settings like I have, you'll end up with a few functions here. The first one will be the ready function, and the second one is usually either physics process or process. But you'll see that I don't have those. That's more of a habit for me. I got so used to designing scripts from scratch that I don't usually tend to have a template. So you can completely clear your template out because we won't be needing it. And all we'll be needing is kind of this setup here. Now, let's hit Control S and save and make sure our player entity script is saved. You'll see down here when I added the ready and physics process functions or methods, they added to this, so I can kind of jump to them by clicking on them in the filter methods box here. For our player entity, we're going to need to have a few kind of variables for what we want to control and what we want it to be able to do, right? We're going to need, specifically, let's go and add one variable for the move_speed. We're going to set the type for this by using a little colon. We're going to set the type as a float. We'll set it equal to 100 for now. We'll do one more for the jump speed. So jump_speed. We'll set the type again as a float and set it equal to, let's go 50 for now. Once again, these are all things we're going to be able to tweak. Now, to save us from having to go back into the code and tweak, because this is prototyping and we don't have any specific numbers we actually have in mind yet, we don't want to sit there and go, well, this is the number we have. We don't know yet. We're going to need to kind of test that out and kind of fiddle around with it to make sure it feels good for us. And that's kind of how I'm designing this. So you can figure out what feels good for you before we move on to the kind of final version of this, before we move out of prototype and into creation, like proper creation. So to do this, we're going to add a keyword in front of our variables here. So just before var on move speed, we're going to write at export. So we're going to use the at symbol, then write export. And we'll do the same thing for jump speed. Now, if I click away from my player entity in the scene view and then click back onto it, we'll have our variables here ready. Now, I'm going to go one step further above our move speed, and I'm going to write at export underscore category. And then I'm going to put a string in here by using my double quotes. And I'm going to write player variables. That way we have these kind of in a little category, which is quite nice. And then we're going to want one more below this. And we can export this one. Actually, we might just export this one for now. So at export var, we're just going to call this one gravity. We're going to set this equal to a float. Or we're going to set the type as a float, and then we're going to set it equal to, let's go 9.8. I think that's the rough Earth gravity. I might be wrong there. And I'm going to add a category above it again. And I'm going to just call this one world variable. Now, you might sit here and go, well, why do we have world-related variables on our character? Well, we'll kind of get into how we're going to be separating this stuff and applying this stuff in a more kind of complex way in the future. But for now, where all we want to do is get our player moving around correctly. This will be fine. So one normal kind of habit here is to, when you're first kind of learning, is to start kind of throwing things into the physics process and just going with that. Personally, I feel like that can build a kind of bad habit. You don't really want those bad habits because it can get a bit hard to kind of debug your code and change things. And that's where functions come in. Functions are really kind of important for stuff like this. Now, what do I mean? So let's take handling input and moving a character. We'll do this in the physics process for now so you can kind of understand. You don't have to follow this, but if you like typing, you can. So let's say I'm going to pseudocode this real quick with a hashtag, so it's a comment. Let's say I go, we get our input, and then based off of our input, we move character, and we kind of start coding things out in this way, right? So this would be an if statement. This would be if our input is X or Y, or forward in the X or back in the X, do something to the character. And then we'll add, I don't know, player death, and then we'll add how hitboxes function, and we start adding all of that into the physics process. It can get a bit overwhelming and complex in like a readability sense. So what we're going to do is we're going to write pass in the physics process for now. The reason why I write pass, all this does is says, don't do this, don't do anything, just ignore this function entirely. There's nothing in here to do. And the only reason why I will write out a function and then write pass into it is usually because I just don't want it to throw up an error. If I don't do that and I click away and I give it a second, it's going to get really angry with me and be a bit grumpy, and we don't need that extra sass in our lives. Coding is already quite sassy. So let's look into the kind of functions we're going to want. Well, the first thing we're going to want, of course, is our character's kind of gravity, right? We want gravity applied to our character. So how do we plan on doing that? It's actually really, really simple. We're going to write func, so we're going to create a new function, and we're going to just call this apply underscore gravity. And we're going to want to have a parameter in here. We're just going to call this parameter. It's going to be the type of float, and we're going to call it delta. And then we're going to put a little line and an arrow, and then void. So if you look at this very quickly, this is for basically going, this has no return type. It's not returning anything. I want to make sure that the kind of engine knows that there's nothing that it needs to return. This isn't entirely necessary. I like doing it. Now I'm going to press enter and go into the function. So how do we apply gravity? Simple. We grab our player's velocity, so velocity, and then we are grabbing specifically the y component of that velocity. And to do that, you just use dot as an accessor. So we're going to access and grab the y. Then we're going to write plus equals. And we're going to add the gravity. And then we're going to times that by delta. Oh yeah, did that backwards. We want delta and then float. There we go. So we're going to want delta as a float parameter, and we want to grab the velocity.y and add, so plus equals meaning add to, or keep adding, gravity times delta. Now, what is times delta? Well, delta is the time between frames, or time frames take, something along those lines. Basically, doing it like this allows it to be frame rate disconnected. It disconnects it from your frame rate and allows it to function at a set speed all the time. Meaning, if it wasn't like this, if your frame rate was really, really high, like thousands and thousands of frames, it would be applied thousands and thousands of times faster. We don't want that. We want something set for kind of every computer that can actually play this game, right? We want it all kind of the same, so nobody runs into any weird issues. So we're now applying gravity. Now, we're going to want to call this function in the physics process. To do that, all we do is write apply gravity in the physics function, and then we want to pass in delta. As you can see, physics process has delta inside of it, and apply gravity takes in delta. So that handles that. Now, how do we want to actually make sure that this is being applied to our character? Right? How do we get the character to go, okay, I need to do things? Because it's not actually just as simple as just calling the velocity and setting it to something. Setting the velocity won't do anything. That's kind of like loading the bullet into the gun, right? We need the trigger pull. We need something that actually pulls the trigger and goes, okay, this is what's happening now. Fire this thing, do this thing. Now, to do that, at the very bottom here of our physics process, I'm going to add an extra line. And I'm going to write move and slide. Move and slide does something kind of fun and specific. If I hold down Control and click on move and slide, it's a built-in function for character bodies. As you'll see here, moves the body based on velocity. If the body collides with another, it will slide along the other body. This is kind of something really, really interesting and fun for us. There is another version of this called move and collide. Now, move and collide will basically move, it'll collide with something, and then it will return the collision. We just want to move and slide, meaning if it collides with something, we want to slide past it or slide on it. So with that done, let's hit Control S and save. Let's go back into our main level, or our main scene, and then under the entity container that we set up in a previous part, we're going to use Control Shift A to add or instantiate a child scene. Then we're going to add the player entity. Now I'm going to use my move tool to just kind of move around our player a bit, and I'm going to plonk him right here. Now I'm going to put him just above the floor so we can kind of see what's happening. Now, if I press play, something kind of fun is going to happen. I'm going to hit play here. So I'm actually going to press play with the F5 key, or the actual play button up here. What this will do is ask you, it'll say, no main scene has ever been defined. Can you select one? So we're going to hit select current, and we're doing this on the main scene because what this does is it selects what the actual main scene the game will run is. So I'm going to hit select current, and we have nothing. We have literally nothing. We just have the bottom of our map. Now, the reason for that is because we don't have a camera yet. Now, I'm going to go to the player entity. I'm going to add one more thing, and this is going to be a very temporary placeholder for our camera. I'm going to hit Control A again on the player entity to add, and I'm going to add a camera 2D. There we go, camera 2D. Now, if I scroll out, you'll get this new pink box around our player. That is the camera's view. So this is how much the camera can see. Now we can zoom this in. We can put this up to 2 and it'll pull it in really tight to our camera. For this, we might want to go for, let's go 1.4. That seems a bit more fair, a little bit better, a little less zoomed. Hit Control S to save. Now remember, as I said, this is a very temporary placeholder for our camera, but we just need one to function. So we're going to go back into main. We're going to hit play. And you'll see our character is now falling and it's colliding with the floor, but it's falling very, very, very slowly. So to test this, we can click on the player entity within our entity container, and we can start moving our gravity variable. 9.8 seems a little bit too slow. So I'm going to go knock this up to 15. I'm going to hit play. And that's still a bit slow. Let's knock this up to 50. Let's go really big with this. When you type this in, by the way, make sure you press enter and click away from it just to make sure it's set. Sometimes it doesn't always set. It's a bit of a weird one. We're falling just a little bit faster. Let's go even higher. Let's go up to 200. There we go. I'll take this 3 times higher, go up to 600. That feels a little bit smoother. Now, there's a bit of an oddity with gravity here, and this will always be applying gravity, right? Which means if it's always applying gravity, if we walk off of an edge and our velocity.y has been added so much that it's up into the tens, 20,000s, as soon as we walk off a ledge, we will just disappear. We'll move so quickly down that we will just disappear. So a really quick fix for this is to sit here and go and do an if check. We're going to do an if check right here in the apply gravity function for if is underscore on floor. Is on floor is a built-in function for character bodies. What this does is it's a Boolean return, so it will return a true-false statement if our character is touching the floor. So if our character is touching the floor, apply gravity. Well, we don't want it to apply gravity when we're touching the floor. We want it to apply gravity if we're not touching the floor. So we can either use the not symbol here, i.e. the exclamation point. We can write equals false and remove the exclamation point if you want to see that a bit better. So we're going to leave it like this for now. Hit Control S and save. Go back and press our play button. And nothing changes, right? It's the exact same, it's completely normal. Perfect. Now let's go into our remote view. We'll go into our entity container, we'll click on it. And you kind of get to see some of the really cool things within player controllers and kind of character bodies and stuff when you're doing stuff like this. Now you can see even better if you go and use some of the debugger stuff, but we'll get into that a bit later. Debugger stuff can be a bit complicated sometimes. So with this doing what we want it to do, we now need to figure out how we plan on getting our character to move. Now, there's once again a very simple way of doing this, and I was kind of explaining functions a little bit and I kind of stopped. And it's because I wanted to actually show this a little bit more before I kind of dove into the explanation. But you'll notice that what we're doing here is we're separating these 2 lines of code here are separated into their own function and they're doing a specific thing. That's how we want to use functions. We want to design functions to do one specific thing. That's it. They only need to get one job done and do that. What that allows us to do is in the future when we want to go through our code and change something or modify something specific, we can just look at the name and go, okay, that is applying gravity. I want to change the kind of math around that a little bit. I want to change other things. I want to go, whilst you're applying gravity, I want to, I don't know, let's do another if check if we're in space. If we're in space, reverse gravity, or make it so there's no gravity. And that's kind of what separating into individual functions like this is. Now, there is a caveat to that. Don't go too overboard with it. You don't always need a function for everything, just most things, usually. So let's go and add another new function. We're going to call this function handle movement input. So we're going to write func handle underscore movement underscore input. This will be a float return type. So we're going to write a little minus sign, a arrow, and then we'll type it as float, and then cap it off with a colon. We'll move into it, and then we're going to write pass. Now, one thing we have yet to do is actually set up our inputs. We need to set up inputs to allow us to kind of use the keyboard controls that we actually want to use. Now, to do that, we're going to do something very simple. We're going to come all the way up to the top here into project settings. Now we're going to move into this tab here called input map. And you'll see that there are no actions here. Now, if I hit show built-in actions, you'll get to see all of the UI related actions and inputs that we can use. We don't want to mess with these, we don't want to modify these, and we don't want to use them. So I'm going to untick show built-in inputs. I'm going to add a new action. This new action is just going to be called move underscore left. And then I'm going to add another one for move underscore right. And because we're going to want our character to be able to jump, I'm going to add another one for jump. And now we have our actions, we need to assign keys to them. Really simply put, all you have to do, come to this little plus arrow or add event arrow icon next to the action. You do that, then you just press the keyboard button or keyboard key and it will give you the input. As it says, it's listening for them. So for move left, I'm going to want the A key, but I'm also going to want the left arrow key. And that is how you bind two keys to one movement or one action. And you can do this for all of them. So for move right, I'm going to want the D key, and I'm going to want the right arrow key. And then for jump, we'll use the space bar. And usually for jump, you can actually just have one because no matter how your keyboard is set, you can usually just use one. But I'm also going to add the up arrow to jump. And then that's it. That's our actions done. So I'm going to close this. I'm going to come back into our handle movement input function. And I'm going to delete pass. And then all I'm going to have to write here is return. But we need to return a float. Because if you remember correctly, we set this so it needs to return a float. Now, the float that it's going to return is actually, this is a kind of fun little trick that I figured out. If you just write input, so we want to access the input functionality. Then you put a dot after input. And then we want to check the get_axis. So getting axis is getting between a negative and positive, right? Usually you use this for controllers. So you want to get between -1 and 1, so between left and right. And it will return a value based off of that, a floating value specifically. So for our inputs, we're going to want move left. And then we're going to want move right. Make sure you put a little comma in the middle of these to make sure they're two separate functions or two separate variables. I'm going to remove that little space to kind of clean this up a bit. And now our movement input is done. That's it, it's done. If we really want to check this, what we can do is we can write into our physics process here. We can, at the very top, we'll go and do a print statement. And then inside, we'll print the handle movement input. Now, if we just do this, it can be finicky. It will either work or it won't work. So what I'm going to do is what's known as a string conversion. To do that, just before handle movement input inside of the print function, I'm going to write str. This will convert something into a string. And then I'm going to wrap the handle movement input into, the function here, into the string conversion, like this with parentheses. And I'm going to hit Control Save or Control S. So what is this actually going to do? This is going to, if I press play and you pay attention to the output here, it'll start typing something. Now, if I use A and then D, you'll see that we're getting between 1 and -1. Now, if I press both, 0. So that gives us a good variable for our left and right, right? We're now getting like a floating value between left and right. Perfect. Now what we want to do is kind of check and make sure that that's working. We won't need this print statement up here anymore, and we won't need to be calling handle input up there anymore. So let's create a new function, and this one's going to be called handle movement. So this is going to be specifically for function handle_movement. We're going to give it a void return because it doesn't need to return anything, but it's going to need parameters. Specifically, it's going to need a parameter for delta, which of course, again, is a float, same with gravity. Now all we have to do is check. We have to check the handle movement input function and whether that is going left or right. To do that, all we do is we'll write if, and then we'll call that function. So if handle movement input, and we'll check, is it less than 0? So if it's -1, what do we want to do? Well, we can just grab our velocity. We want to grab the .x part of that. And we want to set that equal to the move speed times delta. And now we'll do it again. We'll create another if statement inside of the handle movement for if handle movement is greater than 0, velocity dot x is equal to the negative move speed times delta. Then we'll hit Control S and save. handle movement input. Yeah, typo, my bad. And now what we're going to want to do is inside of our physics process, just below our apply gravity, we're going to want to call handle movement, not handle movement input, just handle movement, and pass through delta into the parentheses. Hit Control S and save. Now we can actually go test this. Let's go test. We'll hit F5 to load up our game. And we'll press D, and you'll notice that I'm moving in one, the opposite directions, and two, very, very slowly. So first, let's go into our function for handling movement. Let's reverse these. So if our movement speed is, or our handle movement is going left, i.e. it's in the negatives, we want to use negative movement speed. And if it's in the positives, we want to use normal movement speed. S. Now that handles the speeds. Let's go and do two things. Let's check gravity here is at 600. And now I'm going to go back to the player entity. I'm going to player entity scene. I'm going to click on the player entity. I'm going to change gravity here in its own place, or its own scene. This way, this actually gets saved across any time we want to use our player entity. I'm going to change that to 600. Now I'm going to change the movement speed. So the movement speed at 100 was very low. Let's go for very, very fast. Let's go for 1,000. And then we'll hit run. And we'll move left and right. And you'll see that's still quite slow. Now, this is actually the downside to moving delta. Using delta will kind of make it so you have to use much larger numbers to kind of tweak things. And that's entirely fine. But you'll also see this interesting problem. My hands are off the keyboard and yet I'm still moving. Now, why is that? Well, that's because we're never setting our velocity back to 0. So a really easy way of doing this is at the very bottom of our script here is to just grab our velocity, our .x, and then set it equal to 0. Hit Control S to save, go back into play, make sure it's working, and oh, wait. That is a little bit wrong. Let's set it up the top here instead. And now it's functioning fine. If I let go, it works. Now, the reason why, you might think I did that accidentally. It's actually quite on purpose. This is known as an order of operations issue, right? If I set my velocity.x at the very end of the function to 0, it's going to register whichever one of these is happening, which will change the velocity, and then it's going to set it back to 0 because 0 is being set after these move speeds are being applied. And because this is happening so instantaneously, we're seeing no difference in our move speed or in our velocity. So we want to set that first, which means it will do this. And then after we've let go of this key, it'll do this. So that kind of just makes it a thing to keep in mind. We always want to keep our order of operations in mind, and that's the other reason why we like functions so much. Because if we go to our physics process, we need to make sure that our move and slide is used after anything that affects our velocity. So we want to put anything that can affect our character's velocity or kind of physics in that way before move and slide. So with that done, we want to go and tweak our movement speed even more. It's still a bit too slow. Let's crank this up to 3,000. So let's 3x the speed. That's a little bit better, but it's still a little bit slow. Let's go up to 5,000. That feels much, much better. Now, a very quick thing is I'm going to show this off really quickly. This is kind of not completely to do with the player entity. This is a debug related thing specifically, and it's a bit more kind of advanced compared to what you're doing right now, but it's always a good thing to keep in mind. I don't like how this window is so small. So what I'm going to do is I'm going to go to project settings. I'm going to go to general, down to window. I'm going to toggle the advanced settings. And you'll see here that we've got a bunch more settings, specifically the width and height override. Now it says here, on desktop platforms, override the game's initial window width and the initial window height. Now we can change these. We can override this to 1280 by, let's go 720. We'll click away, or we'll click enter, make sure it's saved, hit close, hit play. And there we go. Now it's much bigger and I can see a little bit better. That's perfect. Now the final thing that we want to do is add some jumping. So we have this handle movement up here, handle movement input. Between the handle movement function and the input version of that function, I'm going to add a new function. This is going to be called handle underscore jump underscore input, parentheses, and this is going to have a return type of a Boolean. So we just needed to return true or false. This specific function is when I say to you, this is not necessary. We do not entirely need to do this, but just for now, it's a good practice and good habit to get into when you're typing functions, is like setting your return types to what you need it to be and a few other things. So for now, we're just going to do this. We're going to return the input dot. Now, I would suggest if you want to, you can try pausing the video and figuring this bit out for yourself. If you don't want to, what we're going to write is underscore action just pressed. We're going to grab jump. Now, what this is going to do is go, okay, if this action has just been pressed, return true. If it has not been pressed, return false. So with that out of mind, or with that in mind, let's go at the very bottom of our script here, and then just go func. We're going to call this one handle underscore jump. It's going to be a void return type. It's not going to need any other parameters. We're going to write if handle jump input. So basically, if that is true, we're going to want to grab our velocity dot y, and we're going to want to set that equal to the jump speed, but we're not going to want to set it equal to the jump speed itself. We want to set it equal to the minus jump speed. So pluses in Godot engine, basically, if you go plus in the y, you're actually moving down. We want to move up, so we're going to need to go negative jump speed. We're going to want to use a negative there. And that, Control S and save. If I go up to our physics process here, I'm going to put handle jump. I'm going to call that just after our handle movement. Hit Control S and save. I'll hit play. And then I'm going to press space. Now we're jumping. We are actually jumping. Not only can we kind of spam jump and kind of fly, or struggle to in this case, we're not jumping that high. And that is because of our gravity. So gravity is at 600. We're going to knock our jump speed up to 800. And now that is a little bit too fast. Or a little bit, about 300. Let's go half of our gravity. That doesn't actually feel half bad. Yep, okay, half of our gravity, so 300 in jump speed. Hit Control S to make sure it's definitely saved. And that's our variables set and sorted. Now, if you didn't want to use these massively large variables, you could just remove delta from things. And there is actually a way of removing delta but having the same effect as delta without having to have these massively increased numbers. And we can get into that in the future when we get to the more complex stuff. But yeah, that actually handles our movement and jumping of our character. Now, there is one more final thing that I'm going to teach you in this episode part. And this is going to be very quickly flipping our character. We're going to write func. It's going to be handle underscore flip. It's going to be a void return. And we're going to do one if check, two if checks technically. We're going to write if, then we're going to grab our velocity dot x is less than 0. So if it is less than 0, we're moving left. We are going to want to grab our player sprite and flip it. Now, question is, I'm going to write flat pass in here. How do we gain access to the player's sprite? Because we can't actually just write sprite. It doesn't know what sprite is. We could use the $sign accessor, so $, and then we could go sprite, and you'll see here that we've got this path variable for the sprite 2D. We could do that, and that is a completely fine way of doing it. Or you can come up to your sprite, you can grab it by holding down left click and grabbing it, you can drag it into the script, and before you let go, you can hold down Control, and it'll create an onReady variable, which is basically just going, this is my sprite 2D, I want that set ready and done. Then you can go one step further after this and type as And we want to set this as a sprite 2D. Now, setting this as a sprite 2D, not entirely necessary. It's just useful sometimes with specific custom classes that we'll be using in the future, and we'll be going into classes as well. Classes can get really fun and really useful. But for now, this is kind of all you need to know. We're typecasting it as a sprite, and it is a sprite. We're going to scroll all the way down. Now we just need to grab our sprite and use it, right? So we have the variable for sprite2d. And then we want to set the dot flip h, which is, if you remember correctly, the thing that we used to flip the sprite originally to make it face right. We're going to want to set this equal to false. Because in this case, the flip h has been set to true already because we want it to go from looking left to looking right. So we want to flip it back. So that's how we flip the sprite backwards. But we're also going to want to do another if check for if the velocity dot x is greater than 0. We're going to want to now do the opposite. Sprite2d dot flip h equals true. Now, you could do this in another way. The reason why I'm doing it specifically like this is because I like it so if I'm moving left and then I stop moving, basically it goes to 0. It doesn't flip anything. It just keeps my character looking in that direction. I just prefer that. It feels a lot more comfortable. Now we just have to call this. Now, as I said before, anything that kind of interacts with our character's physics or our velocity, we want that above move and slide. But where our flip h is only checking velocity, we need this below our move and slide. So we're going to call it below our move and slide. Now, why are we doing that? Well, our velocity is getting set and kind of used through move and slide, which means after move and slide, when our velocity is already doing its thing, we need to check it. Then, that's actually where we need to check and flip our sprite. So Control S to save, go back into the game. Moving right, we look fine. Moving left, we now look left. And if I let go, everything is fine, dandy, and awesome. And if I jump, see, we now have this problem of we can always jump repeatedly. To fix that, all we have to do is check if, so you see the if statement we have here for handling our jump. All we've got to do is check if handle jump is true, and then we're going to use a double ampersand sign, or we can just write and. So we want to check two things. If that is true and is underscore on floor is true. Doing this basically means we can only jump if this is true and this is true. So the other way I said of doing this is instead of writing and, we use double ampersands. This is just another short form operator way of doing and, but we'll just use and because it's a bit more easy to read. Control S and save, go back in, hit enter, we can jump, and if I mash enter or mash space, we can only jump once, and that's only when we're touching the floor. Now, we'll redesign the system and a lot of these systems as we kind of move forward and want to do more things, like double jumps, for example. But that actually about handles the basic movement of our player. And we've set this all out into individual functions. I can collapse all of these here. We'll collapse the physics process as well. And you can see we've got this kind of clean and readable way of doing things. And I said at the start of this as a quick note that we'll be moving into something known as a handler/component system. Well, that's the other reason why we have these separated, and it'll just make our lives easier in the future. But get used to doing things in functions. They're really useful. It allows you to really easily design things and expand upon things. Anyway, that will be it for now. So I hope you have had a great day and you are having a great game dev journey, and I will see you in the next video.